Hello students, welcome to the first lecture on the lecture series on area and perimeter of basic geometric figures. Okay, so in this lecture we'll learn some basic geometric figures and we'll learn what area is, what perimeter is, and how it is different for different geometric figures. Okay, so let's start this topic and get some concept about it. Okay, so we'll be covering the concepts and theory on what? On area and perimeter of basic geometric figures. Okay. So, understanding the concept of area and perimeter help us quantify and comprehend the space occupied by these shapes and their boundaries. Okay, so let's start and see what is a rectangle. Okay, so a rectangle is a quadrilateral. Okay, so basically there are four sides. Okay, that is why it is called a quadrilateral with four right angles. Okay, so the angles, the interior angles are all 90 degree. As you can see here, this is 90 degree, this is 90 degree, this is 90 degree, and this is 90 degree. Okay, so this means that all four angles in the rectangle are of 90 degrees. Okay, so what are the formula used for rectangle? Okay, so opposite sides are equal. Okay, so as you can see here, these two sides are actually equal. Okay, so the length of this side and this side is actually equal, and the length of this side and this side are actually equal. Okay, so this side and this side are equal, and this side and this side are equal. Okay, and all the four angles are of 90 degrees. Okay, so this property ensures that the shape has a symmetry. Okay, so what is symmetry? Okay, symmetry means if we could place a mirror right here. Okay, so if we could place a mirror right here, okay, its image will be right here. Okay, it will be overlapping with this shape. Okay, that is what symmetry is, and same goes for this diagonal too. Okay, so for diagonal symmetry, it is important that the opposite sides are actually equal. Okay, so these two are equal and these two are equal. Okay, so resulting in symmetry around about the diagonal. Okay, so what is right angle? Okay, all four angles in a rectangle are right angles, that is 90 degrees. Okay, so this property results in perpendicular sides that form the corners of the rectangle. Okay, so diagonals are equal. Okay, so the diagonals of a rectangle are congruent, have the same length. Okay, and bisect each other at their point of intersection. So this intersection point is the midpoint of each diagonal. Okay, so basically what? The two diagonals, as you can see right here, these are also the same. Okay, so these diagonals are of same length. Okay, their length is actually same. Okay, so the diagonals of a rectangle are congruent, have the same length, and bisect each other at the point of intersection. Okay, the intersection point is the midpoint of each diagonal. So this point, so this is the intersection point, right? So it is actually the midpoint. Okay, if so, these two have also same lengths. Okay, and these two have also same lengths. Okay, because this will be the midpoint of the diagonal of this diagonal. Let it be denoted by d1 and let this be denoted as d2. Okay, so this is the midpoint, and these two segments are of equal length as they intersect at their midpoint. Okay, so let's see some other properties of rectangle. Okay, so adjacent angles are supplementary. Okay, so adjacent angle of a rectangle are supplementary, means their measure add up to 180 degree. So this property is a consequence of the right angles formed by the sides. Okay, and opposite angles are equal. So the opposite angles of a rectangle are equal because all the angles are actually 90 degree. Okay, so they must be equal because all have angle 90 degree, right? So this property contributes to the symmetry and balance of the shape. Okay, so as you can see that we have a symmetry about diagonal, about d1 and d2 both. Okay, we also have symmetry about this. If we try to take the midpoint here and midpoint here and draw a line about this, we will actually find symmetry about this. And if we draw at the midpoint, we get the midpoint of this length, width, and this side of the width. Okay, and we draw a line about it. Okay, we'll also find symmetry about this axis. Okay, so there are a lot of axes at which we can actually get symmetry because of all these properties. Okay, that actually encourage symmetry. So let's see what area of a rectangle is. So area of a rectangle is the product of the length and width of the rectangle. So A is equal to length into width. that is L into W. Okay, so L is written here, W is here, L is here, and W is here. So basically area will be what? So basically the area occupied by this shape will be equal to length into width. Okay, width is this side, the smaller side, and length is called as the longer side that is available in the rectangle. Okay, so given a rectangle with some length and width, we can actually evaluate its area. If its length is what? 2 meter and width is 1 meter, then area will be what? 2 into 1 meter square, right? Because meter into meter, so it will be 2 meter square, right? So let's see what perimeter is. So perimeter of a rectangle is the sum of all the sides of the rectangle. Basically how much it covers. Okay, how much it covers in length. So this will be added with this one. So L plus W, then plus L, because we want to calculate this boundary also, so it will be L, then plus W. Okay, but it is equal to 2L plus 2W, that is equal to what? 2 into L plus W, right? So perimeter will be equal to 2 into length plus width. Okay, so let's see what diagonal D is. So the line segment connecting two opposite corners of a rectangle. So D is equal to what? Length square plus width square, square root of length square plus width square. Okay, so as we have a rectangle right here and we have a length and a width here. Okay, so D will be what? The length of the diagonal will be equal to square root of length square plus width square. Okay, so what is a square? Okay, square is a, basically square is what? It is a rectangle, but which rectangle have actually length is equal to width of a rectangle imply what? A square. Okay, so a square is a four-sided polygon where all the four-sided sides have the same length and all four angles are right angles, that is 90 degree. Okay, so as you can see here, this is nothing but just a rectangle. All the angles are of 90 degrees. Okay, this angle is 90 degree, this angle is 90 degree. Okay, these two are also of 90 degree angle. Okay, and all the four angles are of 90 degree. Okay, and what is the extra condition right here? The extra condition is length must be equal to width. So these are all length. Okay, that is denoted as A right here. Okay, so length will be A here. Okay, so all the four sides have same length. Okay, that is A, and the diagonal length will be same for both. And they, since this is actually rectangle, so all the properties of rectangle will be followed right here, but some extra properties will also appear. Okay, so let's go forward and see those properties. Okay, so all the four sides are of equal length. Okay, that is they are congruent, and all the four angles are right angles. Okay, each angle is of 90 degrees, and opposite sides are parallel. Okay, so this side and this side are actually parallel, this side and this side are parallel. Okay, and opposite angles are same, this angle, because these are all 90 degree. Okay, so this is not a surprise. Okay, so let's go forward and see some other properties. So the diagonals are congruent, meaning that they have the same length. Okay, so this diagonal and this diagonal have same length, and the diagonals bisect, because in case of rectangle also they bisected, and square is nothing but a rectangle with an additional property that length is equal to width. So here the diagonals will also bisect. Okay, so the diagonals are perpendicular to each other. This is the new case right here, that the diagonals are actually perpendicular to each other. So this angle will also be 90 degree, this angle will also be 90 degree, this angle will also be 90 degree. Okay, so these four have actually same angle, that is 90 degree, because they bisect each other at 90 degree. So this will be the midpoint of this diagonal, that is denoted by D1, this will be D2, and this will be the midpoint of all both the diagonals. Okay, where they intersect. Let's see how we can actually evaluate the perimeter. Okay, in case of rectangle, we knew that the perimeter, what was the formula for perimeter? So perimeter of rectangle is equal to what? Length 2 into length plus width, right? But in this case, as you know, what length and width are all same, and that is S. Let it be S. So it will be 2 into S plus S. What is it equal to? 2 into 2S. That is equal to what? 4S. So the formula for the perimeter of a square is 4S. Okay, where S is the length of the one side of the square. So we have four sides of a square. So here, 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 and here. Okay, So the region enclosed by the square's boundary. So formula A is equal to S square, where S is the length of one side of the square. Okay. So diagonal, the distance between two opposite corners of the square. So formula D is equal to S into root 2, where S is the length of one side of the square. Okay. So how we can actually evaluate the length of the diagonal? So here this will be the diagonal, right? So this is the diagonal. Let it be denoted by D1. Okay. So how we can actually evaluate this D1? So if the length of the side be 2 meter. Okay. Then how we can actually evaluate D? So the formula is D is equal to S into square root of 2. So here in this case, D1 will be equal to what? Square root of 2 into 2 meter, right? So it will be 2 root 2 meter. Okay. This much will be the length of the diagonal. So basically, if we are given the length of one side of the square, we can actually evaluate the diagonal. So how we can actually evaluate the S, that is the side, length of the side or one side. Okay. When we are given the area. So basically, how we can actually evaluate area? Let's first see that. Okay. So in case of rectangle, so a rectangle is equal to what? Area is equal to length into width. But in this case, L and S are same. L is equal to W is equal to S, right? So it will be equal to S square. Okay. So how we can evaluate A? So A is equal to S square. This implies that S is equal to what? A, right? So the formula is right here. Okay. S is equal to square root of A. So if we are given the area of a square, then we can actually evaluate the length of the one side of the square. Okay. Actually, length of all the sides are same. So length of the side of square. Okay. So let's see an example. So if A is equal to 4 meter square. So this implies that S is equal to square root of 4 meter square, right? It will be equal to 2 meter. Okay. So given that we have a area of 4 meter square and that area is of a square, we can actually evaluate the one side of the square. Okay, how we can evaluate it? S is equal to 2 meter. That is taking the square root of the area that is given to us. So let's see the properties of rectangle and what a rectangle is. So rectangle is a three-sided polygon. Basically, it is a polygon, but it has only three sides. Okay, it is defined by its three straight sides and three angles. Okay, as you can see here, we have three angles right here. Okay, and three angles. So some key properties and types of triangle include what? Let's see. So inequalities in sides and angles. Okay, so the sum of lengths of any two sides of the triangle is always greater than the length of the third side. Okay, as you can see here. So what it means? Okay, this long point, what it means? So it means that if we take any two side, length of two sides. Okay, let's see first. Let's take this side, this side. Okay, so B plus A is actually always greater than C. Okay, if we pick any two. Okay, so and B plus C is always greater than A and C plus A is always greater than A. Okay. This is what this point means. Okay, whatever the triangle is, okay, what kind of triangle? Any triangle actually. Okay, any triangle that is a polygon with three sides will have this property. That is, the sum of two sides will be always equal to or greater than the third side. Okay, or always be actually greater than. Okay, not equal to. It is always greater than. So this is called the triangle inequality theorem. So if it is asked to us that what is the triangle inequality theorem, but it makes sense. So it tells us that the length of the sum of the length of two sides is always greater than another side or the third side. Okay. So let's see the property, that is exterior angle property. So the exterior angle of a triangle is actually equal to the sum of two interior angles, okay, that are not adjacent to it. Okay, so basically if you have a triangle A, B, C, okay, so these are the interior angles A, B and C. Okay, and the exterior angle is what? D. Okay, so the angle demarcated in yellow line is called the exterior angle, that is what? Outside the interior of the polygon, because the inside area, okay, that area that we actually evaluate, okay, this is the area covered by this polygon or trigon or triangle, right? So the angle outside it with this angle, okay, as you can see right here, the angle demarcated in yellow, so this is called the exterior angle. This is called the exterior angle. Okay, so this is called the exterior angle. This is called the exterior angle. This is called the exterior angle. and this is called the exterior angle. Okay, so these are all exterior angles, and all the angles inside, that is A angle, B angle, C angle, these are called interior angles. Okay, so let's see what altitude, median, and angle bisector is. Okay, so altitude is what? It is a line segment drawn from vertex perpendicular to the opposite side. Okay, so what is altitude? Okay, let's try to erase these things and see what actually altitude is. Okay, so we have a vertex right here. Actually, you have three options, but I am choosing this one. Okay, so what I do is I draw a perpendicular to the opposite side. Okay, so I draw a perpendicular. Okay, this must be 90 degree. So this is the only property that makes it called what? A altitude. Okay, so a perpendicular from this to its opposite side will be called the altitude. Okay, because this will be 90 degrees, so this is called a altitude. Okay, so if I try to draw a perpendicular from here to here, this will be called a altitude. Okay, so what is median? So median is a line segment drawn from vertex to the midpoint of the opposite side. So basically, if you have a triangle like this, let it be denoted by A, B, C. So here is the midpoint, here is the midpoint, here is the midpoint, right? Actually, let's take a versatile triangle so that it actually is different from, and it is basically easy to understand. Okay, so A, B, and C. This is also a triangle. Okay, we have three interior angles, we have three gone there. So this is a trigon, right? So what we do, we first evaluate their midpoint. So let it be denoted by E, let it be denoted by F, let it be denoted by G, right? So what we do, we draw a line from the opposite vertex to that midpoint. Okay, and we try to draw this. And we try to draw this. Okay, so these are all called medians. This is a median, this is a median, and this is a median. So the angle bisector of a triangle is a straight line that divides an angle into two equals and congruent angles. Okay, the angle bisector is drawn from the vertex of a triangle to its opposite side. So what will be called an angle bisector? So an angle bisector will be nothing but that bisects actually this angle. If this is 60 degree, then we will try to manage what 30 degree is here. So 30 degree will be something like this, right? Somewhere like here, right here. So I'll draw a line at that angle. Okay, that will actually bisect that angle, and wherever it intersects, it doesn't matter. Okay, so that line is called the angle bisector. Okay, so this is called the angle bisector. Okay, that actually is a straight line that divides an angle into two equal and congruent angles. So the angle bisector is drawn from the vertex of the triangle to its opposite side. So let's see some triangle types. Okay, so what is scalene triangle? Okay, so all the sides have different lengths. Okay, so here you can see that if this is called ABC, this triangle, and this is AB and C. Okay, so all the sides have different length, then all the three angles are also of different measure. Okay, so this is called scalene triangle. How? Because A is not equal to B, B is not equal to C, and C is not equal to A. Okay, and B is not equal to C. Okay, as we have written right here. Okay, all these three are all different and distinct. Okay, so this kind of triangle is called scalene triangle. Okay, what kind of property they possess? They possess that all the three angles are actually different. Okay, this is alpha, this is beta, and this is gamma. But it will result in a alpha is not equal to beta, beta is not equal to gamma, and gamma is not equal to alpha. Okay, so let's see what is isosceles triangle. So isosceles triangle is nothing but a triangle where two sides have actually equal lengths. Okay, any two sides. Okay, this can be also this and this side, but in this case it is this side and this side. Okay, let it denoted by ABC. Okay, so what kind of property it possesses? It tells us that all those adjacent angles of those sides, that is this angle and this angle. So this angle represents this side, this angle represents this side. These two have actually equal measures. Okay, so these two angles are actually same. So let's see the third kind of triangle, that is an equilateral triangle. So what is equilateral triangle? All the sides have the same length. Okay, so note that every equilateral triangle is an isosceles triangle, but converse is not true. So what is actually equilateral triangle? Equilateral triangle is nothing. So equilateral imply isosceles. Okay, but isosceles does not imply equilateral. Why? Because in conditions for isosceles, what we needed was we needed two sides to be same. So in equilateral, there are three sides same. So it can be right. And there is another condition, that is all the three sides are same in case of equilateral triangle. Okay, that is why all the equilateral triangle are isosceles, but all isosceles need not be equilateral. Okay, so it is just a case of definition. Okay, that makes it different. So triangle angle sum theorem. So the sum of interior angles of a triangle is actually always 180 degree. Okay, so the sum of interior angles of a triangle is actually always 180 degree. So as you can see here, this angle, and these three angles, alpha, beta, gamma. Okay, so alpha plus beta plus gamma is actually always equal to 180 degree. That is what told right here. Okay, so this is called the triangle angle sum theorem. That is the sum of all the interior angles of the triangle is actually 180 degree. Okay, so let's go forward for the other properties and other type of theorems. Okay, so what is triangle inequality theorem? So the sum of length of any two sides of a triangle is actually greater than the length of the third side. Okay, if this is denoted by z, then you can always say that z is less than x plus y, and x is less than z plus y, and y is less than z plus x. Okay, this property will always hold. Okay, in case of triangles. Okay, so let's see the types of triangles by angles. Okay, acute angle triangle. Okay, so all the angles are actually less than 90 degrees, and right triangle, that is one angle is exactly 90 degree, and obtuse triangle, that is one angle is greater than 90 degree. Okay, so what is acute angle triangle? If all the angles are actually less than 90 degree. Okay, so right angle triangle, one angle is exactly 90 degree. Okay, then it is called a right angle triangle. Obtuse triangle, that is one angle is greater than 90 degree. Okay, so as you can see here, this is a acute angle triangle, that is all the three sides have angles less than 90 degree. Okay, here is an example of right angle triangle, that is we have a triangle with 90 degree angle, 190 degree angle. Okay, so obtuse angle triangle, okay, where one angle is actually greater than 90 degree. Okay, I have a brainstorm question for you right now. Can we actually have a triangle with 290 degrees? Just try to think about it. Okay, we actually can't. Why? Because we know that we know this theorem, right? The triangle angle sum theorem. So if two angles have, let alpha and beta and gamma be three angles, and let alpha is equal to 90 and beta is equal to 90, then 90 plus 90 plus gamma is equal to 180. So this implies that gamma is equal to 0. But gamma must be non-zero, right? Otherwise it can't be an angle. If gamma is equal to 0, it is not an angle, right? There is no angle. So for gamma to be greater than 0, two can't be actually equal to 0 at the same time. Okay, so this case is not possible. So not possible. Okay, so I feel that's enough for today. We'll continue the session on the theory of area and perimeter of basic geometric figures in the next lecture. Okay, so thank you.